A burning ball, 93 million miles away. Temperatures reaching up to 27 million degrees Fahrenheit. The Sun. It is integral to life on Earth. A source of great danger and also wonder.
So clear, it's like a planetarium, isn't it?
Throughout history, the Sun has captivated the imagination of artists, philosophers, and scientists alike.
Seeing this machine for the first time and seeing, is this what we asked for?
For those of us on Earth, the Sun is not just any old star. It is the star. Finnmarksvidda is a region in northern Norway. It experiences the coldest temperatures of the Norwegian winter. At the beginning of April, it still is minus 14 degrees Fahrenheit, even during the day. We're on the road with hunters on a special mission.
So we're going to start getting some clear skies this evening as well, and hopefully good weather for the rest of the weekend.
This is Andy Keane, his son Alex, and their longtime friend and colleague, Alan Napier.
Perfect conditions. I'm hungry.
Andy spends many weeks a year north of the Arctic Circle in search of a unique natural phenomenon known as the Northern Lights. When did this adventure begin?
It actually started, believe it or not, from a hospital bed. I was in my early 20s, and I woke up one morning fully paralyzed. But not as people think when they think paralysis, you know, you're all floppy and everything. I was in something called a tetany, state of tetany, so my body was literally rigid like a corpse. And it actually took me about a year to learn to walk again. And then I kind of recovered, made a full recovery after that. And then 4 years later, the same thing happened again. It was a type of peripheral neuropathy, which left me in this state of paralysis.
Andy Keane made again a full recovery.
From that point, I decided that I wanted to help other people around the world who may find themselves in a similar position to me. I spent 15 years of my life helping people affected by this condition. And then what happened next was, in 2008, I saw a documentary, and it was about the Northern Lights. And I just said, imagine if this thing happened to me again and I was paralyzed or facing, you know, death. What would be the last thing that I would love to do if I was able to do it? And it was to see the Northern Lights.
Andy Keane is the Indiana Jones of the Northern Lights.
I think the sun feels more intense.
There is nowhere in northern Scandinavia where he hasn't chased after them. He will spend the next few days aurora hunting with his team in Kautokeino. This is the center of Sami culture in Norway. The Sami are the last remaining indigenous people in Europe. For centuries, they traveled as nomads through the vast landscapes of the north. The sun always had a special mythological meaning for them and found its way into many traditional customs and rites. Traditionally, it is one of the most important pagan spirits of the Sami, but also the driving force of their modern life. In Sami, Kautokeino means in the middle of. It is the historic place where the Sami have met for centuries. And it is one of the best places on Earth to experience the magic of the Northern Lights.
It's pretty damn remote and it's pretty damn cold. The problem with this place was logistics in getting to here because it is so remote. But now it is accessible. We are here. It took a little bit more effort. I think it's worth making that effort because we're in something that is absolutely unique. There's hardly any people around. So at the moment, it's just, we're fortunate to be able to experience this off the beaten track destination before it becomes well known and it becomes inundated with masses of people.
Due to the secluded location, there is very little light and air pollution here. The perfect starting point to experience the wonders of our sun. A star that was formed 4.567 billion years ago. During the birth of the universe, elements such as hydrogen, helium, and iron swirled around for several billion years until these elements coalesced into a huge cloud of dust. This gigantic cloud finally collapsed under its own gravity to form a star, the Sun. Since then, the Sun accounts for 99.8% of the total mass in our solar system. The resulting gravitational attraction holds our solar system together. It keeps the planets in stable orbits and keeps the Earth a consistent distance from the Sun. This is the reason that the conditions on Earth remain constant. In this way, the Sun, quite fundamentally, ensures that life on Earth is possible. Without the Sun, there is neither energy nor life. It's as simple as that. At an observatory on Mount Teide, the highest point in Spain, a world-renowned solar researcher seeks to unlock the secrets of his home star.
The Sun's made up of 92% hydrogen, the lightest element in the universe. The remaining 8% is almost all helium, the second lightest element. Both are so light that they are used in balloons because they rise nicely. All the rest, practically everything that the Earth is made of, makes up only 0.2%.
All das macht 0,2% aus.
Compared to the Sun, the Earth is a microscopic object.
This is the Earth, the blue Earth with the continents on it, 1 inch in diameter. In comparison, the Sun would be a giant glowing ball of gas, 10 feet in diameter. I could fit this marble 1 million times into this 10 feet diameter gas ball.
1 Million Mal in diesen 3 Meter Durchmesser Gasball reintun.
In the same way, you could put the Earth into the volume of the Sun 1 million times, and it would just barely fill it.
Und sie würde es gerade so knapp füllen.
Humans have long been fascinated by our home planet's closest star. A desire to decipher its secrets has moved people from the very beginning. One discovery stands out. In 1609, the Italian polymath Galileo Galilei revolutionized a now familiar instrument.
The telescope itself is not Galileo's invention, but the telescope that turned science on its head is by Galileo. The telescope actually came from the Netherlands. Galileo found out about it at the beginning of 1609 and probably managed to get his hands on one of the first telescopes. He understood how it worked and perfected it from then on. This was the decisive moment. At this point, it became Galileo's telescope, because from the 3 magnifications of the Dutch telescope, he managed to achieve 20 magnifications, perhaps even more.
In one fell swoop, Galileo Galilei possessed the best instrument for remote viewing and used it to observe things that no one had ever seen before.
When he realized that these were new discoveries, his scientific activity became frenetic. At night, he observed, wrote, corrected, and then sent his findings to the printer in Venice, among others. The printer produced the galley proofs, but all the while, Galileo made new discoveries and continued to work on the text. He did this within a tight time frame, from summer of 1609 to March of 1610.
Galileo's discoveries were related to the moon, the number of stars and the composition of our galaxy, as well as the moons of Jupiter, which Galileo Galilei observed for the first time with his newly developed telescope. Galileo wrote, "I have observed stars in abundance, stars that we have never seen before, and that exceed the number of old, previously known stars by more than a factor of 10.
Galileo, who had previously been a math teacher at the university and was basically unknown, became the most important person in the world within a month.
The Biblioteca Nazionale Centrale di Firenze is the largest library in Italy. It houses 93 miles of bookshelves, and more than half a mile is added every year. It's home to the largest collection of original manuscripts by Galileo Galilei. They are the most valuable documents in the library's collection.
And this is the most famous page we have, perhaps even the most famous page in the world.
Galileo made the first precise drawings of the lunar surface with all its craters. A unique document of his scientific and artistic skills. But another eruptive discovery was to follow when Galileo pointed his telescope at the sun. He observed something strange. The sun had blemishes. It was blotchy and impure. Galileo discovered sunspots.
February the 12th, 1612, in fact. He first made the drawings of the sunspots. And then he wrote, here we have the date. At sunset on March the 1st, at the end of spring, there were sunspots. From March 2nd, however, no spot appeared in the east of the sun, and it increased in size as the pulse increased.
Ah, I see. It's about how many heartbeats it takes for the sun to rise.
Exactly.
Osservazioni che cominciano il 12 febbraio 1612 in occaso solis.
During the drawing, he recognized that the sun was obviously moving. He recorded this movement in the drawings so that the sunspots had different orientations depending on whether they were observed at sunrise or sunset. when the sun changed its inclination in relation to the observer. Galileo Galilei thus proved that the sun revolved around itself, while others only suspected this. The sunspots were proof that the sun rotates.
The discovery shook society. Galileo Galilei opened humanity's eyes. Indirectly, his observations of the solar system also confirmed the Copernican revolution, the assertion that the Earth orbits the sun and not the other way round. In other words, man was not at the center of the universe. In Kautokeino, in the north of Norway, Alan Napier wants to show his colleagues sunspots as Galileo Galilei observed them 400 years ago. Well, not quite, with a modern camera and a special solar filter in between.
What we're going to do today is see if there are any sunspots on the surface of the sun using the camera. What I'm using here is a 350mm telephoto lens. With a solar filter, we must never look directly at the sun with our eyes because we can damage them very quickly.
When you've taken the image on the back of the camera, what will it look like? Is it quite big, or are they pinpricks?
The actual sunspots themselves will be quite small. The main image will be a sort of golden or orange picture of the sun, which is what results when you take it through this solar filter. But we should see some small dark spots.
If there are any facing us.
If there are any facing us on the surface of the sun.
And this is what the sun looks like through Alan Napier's camera.
We've now got an image of the sun, and it appears that there are 3 sunspots there. Here, here, and here. There's there is a triangle shape of 3 sunspots.
The dark, blurred dots are sunspots, larger than the Earth in diameter. How exactly they are formed is still a mystery more than 400 years after their discovery.
Good job, Al.
Thanks.
The sun has a very special calendar in the far north, above the Arctic Circle. During the polar night and winter, the sun is not visible at all for 2 months. During the polar days in summer, it remains above the horizon for almost 3 months. Understanding the sun also means understanding how it influences the Earth.
It's crazy in a good way and crazy in a bad way. For normal people living in these regions, they're quite tough times, you know, because obviously there's no light, you've got vitamin D, for example, deficiency, you've got SAD syndrome, you get depression, unfortunately, alcohol intake can increase, etc. So there's all that to deal with, and they're long, long winter nights. And then by contrast, when we have the midnight sun, it's the complete opposite. But then the problem is you should sleep.
A radiant ribbon connects the sun with the Earth. It is invisible to the naked eye, and yet nature aligns itself with it. A lack of natural sunlight throws the human biorhythm out of balance. Too much sun, on the other hand, is dangerous for every organism. Some people have to conquer this threat every day. Ronja Wittmann suffers from a disease commonly known as shadow jumping disease, erythropoietic protoporphyria, EPP for short. It is a very rare metabolic disease. When people with EPP come into contact with light, their bodies react with painful burns under the skin.
The most fitting description for the pain is when it's been really cold outside. You've kind of shoveled the snow and your hands are really frozen. And then you go in the house and wash your hands. And there's a brief moment where the water touches your hands, and because the water is set to very warm, you feel this burning moment. Of course, it normally goes away relatively quickly because your hands warm up. But for me, it's a permanent condition that lasts for several days.
Apart from the unbearable pain, those affected must deal with the fact that they are not taken seriously. The sun becomes an invisible stigma because exposure to the sun is often crucial for human interaction. What happens when enjoying a beautiful summer's day turns into a nightmare scenario?
It was often like that at school. Let's meet at the pond today. I would have wanted to, it would have been fun, but I didn't want to come. And at some point you are not asked anymore. Unfortunately, you spend a lot of time alone and indoors. On bad days, you're already pretty down, pretty much in a hole, and you have to make sure you get out again. It's not always easy. Days like this are terrible.
As a child, Ronja Wittmann did not like to talk about her problems and suffered in silence, which is typical of the disease.
Once again, cooling your feet.
Cooling your feet.
Feet in the well, feet out the window.
Not being able to sleep.
That's how you look when you weren't feeling well, right? Yes. We had sleepless nights. I really didn't know what to do anymore. At some point, you just couldn't believe that it was due to the sun because there were no superficially recognizable changes. It was always just pain. She said she was in pain. And we couldn't believe that, or didn't want to believe it, because she had no visible signs on her skin. That was hard for us. And in hindsight, it's even harder for me because I know now what it was all about. When I think back and say, what did we do? What did we do to that child?
As the disease is not well known, parents and children can often search for answers for a long time. Ronja was not diagnosed with EPP until she was an adult. EPP cannot be cured, but in Ronja's case, the symptoms can be treated with medication. An artificially produced hormone creates a tent layer to protect her skin by tanning and has a strong anti-inflammatory effect. It extends the time she can spend outdoors. With this development, her life has improved dramatically.
I think a lot of people just believe she just sits at home, she can't do anything. You can't do anything with her. But I still like doing things in the sun. Like diving, climbing, hiking outside, playing beach volleyball. What gives me hope is actually that others feel the same way. And also when I've done some cool things outdoors. In retrospect, after a few days or a few weeks, I think to myself, cool, I was able to do that. And I can do something like that again, because I've done it before. And that definitely gives you hope.
Light from the sun is necessary for human existence, both for the body and for the mind.
The sun is structured like the inside of an onion. The outermost layer is the corona. I'm going to take it off here now. The corona has a high temperature of almost 2 million degrees Fahrenheit. It's still not understood how the sun manages to get this part of the atmosphere so hot. Below it lies the chromosphere, the second outermost layer of the sun's atmosphere. This is much cooler, up to 18,000 degrees. Below that is the coolest layer of the solar atmosphere, the photosphere, almost a cozy 10,000 degrees. Then we get to the surface of the sun, and that's as far in as we can see, so we have to use indirect methods to probe the interior of the sun. We know that the convection zone starts just below the atmosphere. Below that comes the radiation zone. And then, at the very center, we're at the core. That's where the energy is produced through nuclear fusion, where the energy in the form of photons, of light, begins its journey outwards to the surface and beyond to us.
The greatest heat is generated in the core of the sun. The immense scale at which the fusion of atomic nuclei takes place there is unimaginable. The closest thing to it is the most terrible weapon humans have ever built. In 1952, the United States of America tested thermonuclear bombs for the first time on a small, populated atoll of the Marshall Islands in the middle of the Pacific Ocean. The first large hydrogen bomb, codenamed Mike, released energy equivalent to 10.4 megatons of TNT. The sun produces many times more energy in its interior. The equivalent to billions of megatons of TNT explode there every second. About 45 miles east of San Francisco, attempts are being made to unlock the secret of this enormous power and harness it. Surrounded by cow pastures and grassy hills, the National Ignition Facility, or NIF for short, is located on the outskirts of the small town of Livermore. The facility was originally built to stimulate nuclear explosions without dangerous tests like those on the atolls of the Marshall Islands. The world's most powerful laser was built for this purpose. It is the place on Earth where you come closest to the powers of the sun.
Seeing this machine for the first time and seeing, is this what we asked for? And yes, it's an effort over the last 60 years to develop the knowledge, the laser systems, the physics, and having it all come together into basically what I call a big step for humankind.
We're on the road with a man who can hardly hide his enthusiasm. NIF Operations Manager Bruno van Wontagem.
The beams are about 40 by 40 centimeters, and each beam by itself is about 20,000 joules. Each of these modules that you can see here are actually a total of 192. Stores about 2 million joules of electrical energy. The only lasers in the facility are these tiny little devices over here. Everything else is just a gigantic amplifier. So what do we do in this facility? We are trying, to recreate a miniature sun in the laboratory using high-powered laser beams.
Building the sun on Earth is an ambitious engineering feat. 192 lasers are housed in two enormous 65,000 square feet, 10-story high halls. and all of the lasers are aimed at one space, the target bay.
Here is where actually the magic happens. So that's where we have the 192 beams of the NIF laser creating the temperatures and pressures that are needed to start a fusion reaction that actually exceeds the temperatures and pressures found inside the sun.
What is being tested is a fundamental principle of nuclear fusion. When fusion is set in motion, the collective energy of the laser is discharged onto a pea-sized gold cylinder. Inside is a frozen pellet containing hydrogen isotopes. It is heated to several million degrees Fahrenheit. At this unimaginable temperature, the atomic nuclei begin to fuse to form helium. In a major breakthrough on December 2022, the project succeeded in releasing more energy than was used to create the reaction.
This is one of the most impressive scientific feats of the 21st century.
Is the promise of an inexhaustible and sustainable energy source of the future now within reach?
For a tenth of a billionth of a second, we created more power from that tiny little target, about the size of a pinprick, than the entire power of the sun illuminating the Earth. So this is the place where, for the first time, we recreated a sun on Earth, right inside of the laboratory, in the middle of this chamber.
However, not everyone is convinced that the power of the sun should be controlled by humans. The success of NIF has been criticized by the research community, especially with regard to the calculation of the energy surplus. Either way, nuclear fusion remains a dream for the time being, but Bruno van Wontgehen's euphoria is real.
For the first time, we can say ignition is over a year ago. So I feel incredibly proud being able to work with incredible scientists and engineers and come together in basically a Disneyland, for science and engineering.
The secret to the sun's immense power, will mankind actually succeed in harnessing it one day? The potential technological advancements made possible by the sun are not being discussed here. Andy Keane and his team spent the evening in a traditional Sami tent outside the town, the Lavu. The indigenous inhabitants of the north, the Sami, treat our closest star with the respect of a people close to nature. Their everyday life revolves around reindeer herding. They sing about people, animals, and natural phenomena like the sun in their traditional song, the Joik. And the tent is also full of ritual sun symbolism. Even its orientation is no coincidence. Towards the east, where the wind rarely blows and where the sun rises. The Sami call our home star Father Sun and our home planet Mother Earth.
That's true, because before we get the Christianian over to us in the 1850s, before that we had many gods that we believed on. We had gods for the fireplace, we had God for the reindeer herders, we have God for the pregnant woman, and we had almost God for everything. That's what we believed on. And the reason why we believed on that is because when we are herding the reindeers, we are most of the time alone. So we have to believe on something, or we have to hope they are there and helping us.
It's a real insight into a completely different lifestyle. And the interesting thing is, you know, we're really excited about the aurora, but the Sami that live here, you know, it's almost during the winter and autumn months, it's almost a nightly occurrence. So for them, to some extent, they may take it for granted.
We don't really like aurora, and because when I was a kid, my mother used to tell us that kind of story, that if you are outside in the late night when we have many aurora, if you're teasing the aurora will come down and make you and all of your family and your reindeer herd over to be a stone. I never watch out really, because I am growing up with that kind of stories all the time. And I remember once I asked my mother, why it is so many different colored in aurora? That's very easy answer on that. Because aurora has picking up so many different kids with the different skin colored. That's the reason why we have so many different colored of the aurora. Why my mother are telling us this story is maybe that my mother wants us to come inside the lavabo when it's late. Maybe, I don't really know. But I'm a little bit over 40 years now, and I'm a little bit afraid for the aurora.
The birth of the aurora takes place almost 93 million miles away, on this wonderful star that is the source of life on our planet, the Sun. In addition to light and heat radiation, huge quantities of material are constantly being evaporated from the Sun or hurled into space by eruptions. Science speaks of the solar wind. This electromagnetic storm consists mainly of protons and electrons. Exactly how it is created is still one of the great mysteries of science. When these storms reach the Earth, something strange happens. An invisible shield, the Earth's magnetic field, deflects the storm and forms a funnel to the poles.
And when it does that, it's drawn in towards the poles, the North and the South Pole, where it interacts with molecules of gases, for example, oxygen. And then they get energized, and this is a very basic description, but they turn into something called photons, which are light cells, and they emit certain colors of light. So, for example, oxygen produces green and can produce, you know, pinks and magentas and this kind of thing. And then what happens is that's not a natural state for them to be in. So they're desperately trying to lose energy, to dissipate energy. So when we're looking up at the night sky and we see it glowing and we see it moving and everything else, and then suddenly it fades, that's the aurora losing its energy. But don't give up, because that can get re-energized because it's being bombarded all the time and being charged. And then eventually, of course, it will lose all that energy and everything returns to a state of equilibrium, and then it disappears. And everybody goes, boo.
Tonight is the night the Northern Lights hunters have been waiting for. The weather forecast is good, creating the best conditions to see the elusive lights for the first time on this trip.
What's the temperature?
Minus 22.5. That's good.
The men are on their way to a place they already know.
The sky.
They call it the planetarium.
Here we go.
This is the one.
I think we get the camera set up pretty quickly and try and capture this. Perfect.
Whoa. That's great.
Wow, look at that.
A 100%. I said thousands of hours underneath it, and it never gets old, eh?
No. That's a beauty.
Yeah, it really does look like a fox. You can see the tail coming off it.
Yeah. There's pencils in it as well, look,
Yeah.
as well as the band. There's a lot of movement in that. I'm going to try and capture this wide angle. So still.
It's so clear, it's like a planetarium, isn't it? Literally.
You never get tired of it, Al.
Absolutely not.
It's just really, for me anyway, it kind of puts life in a perspective. You know, you feel like more at ease out here in the nature. And just soaking all of this in, it's just magical. Truly magical. Some people in Norway say that the auroras cause there's so many fish in the Norwegian Sea, it's the reflections off the scales in the fish. And in Finland, they call this revontulet, which means fox's fire or fox's magic. And it comes from the tail of the fox brushing through the snow and creating this aurora, shape in the sky. I think it means something different to everybody. The beautiful thing for me is watching grown adults turn into children for 5 minutes, and sometimes I've seen people running down here, screaming, with joy, and it's just amazing. And then forget about their emails and forget about the work and just be at one with nature and connect with that nature, which is, I think, something that we all need in our lives.
You could say it's a living thing, because it is constantly changing. There's the cloud directly overhead.
The sun holds another secret. It follows a mysterious cycle. Every 11 years, its activity increases and then decreases again. An invisible heartbeat of the solar system from minimum activity to maximum activity, the course of which science is still unable to explain. During the peak phases, billions of tons of material are constantly hurled into the solar system, coronal mass ejections, sometimes several a day. Most of them do not even get close to Earth and are largely harmless to humans, but they can cause enormous problems for technology. September the 1st, 1859. Miners who followed the gold rush in Colorado reported that the night sky was as bright as day. In London, it was said that you could read the newspaper at night with the naked eye. The blazing glow could be seen as far away as Havana, making people believe that nearby towns had caught fire. This was the largest scientifically observed magnetic solar storm to date, the Carrington event. Telegraph lines caught fire and thus the rudimentary communication technology failed. In 1989 and 2003, comparatively weak solar storms paralyzed large regions of North America and Canada.
No emergency backup systems go on. Employees use their cell phones to guide people down the stairs.
There is no subway, there are no buses, there are no streetcars, nothing for now. We're all stuck together.
I'm not able to contact my husband on cell phone. I don't know about my kids. You know, it's all...
For some reason or other, there was a power failure in northern New York or southern Canada.
We are part of, caught up in, one of the biggest blackouts in history.
There is no question that if the Earth was to hit by a solar storm as powerful as the Carrington event today, it could literally devastate our planet's networks. To prevent this from happening, work is in full swing here. The Heliophysics Division at NASA's Goddard Space Flight Center in Greenbelt, Maryland. Alex Young is Deputy Science Director and a sun nerd in the best sense of the word. He even wears shoes that pay homage to the home star.
The sun is special because it's so close. The sun is only 150 million kilometers away, which seems like a long distance, but in the scale of the universe is actually quite short distance. It allows us to see amazing detail of what's happening, see sunspots in incredible detail, to see the surface of the sun moving and swirling. We can't do that with any other star in the universe.
More scientists conduct research on the sun in this building than anywhere else on the planet.
We will see if my colleague Nick is here.
We are building an instrument for the space station, to put it on the space station. And the goal of this project is to be able to continuously study the dynamics of the ring current.
All of this matter and energy coming from the sun is basically energizing our upper atmosphere, creating huge electrical currents. And those electrical currents are driving the beautiful aurora, but they're also driving these what we call geomagnetic storms that are creating electrical disturbances which are impacting our ability to use our cell phones, our GPS, our ability to communicate, and in the most extreme situations, it can even impact our power grids. So that's certainly a huge concern, especially for the largest events. So this is a really, really important beginnings of how we can get the kinds of data, real-time dynamic data, to help us understand these unbelievably complicated systems. We understand a lot of the fundamental physics, but at the same time, there are some details about how the sun's magnetic field is generated inside that are still so complicated that while our computer models give us some idea of what's going on, there are things that they don't answer. There are connections that they don't reveal. So we have a lot more to learn. I think that to say that we truly understand it would be naive. Part of it is that we always find more questions. So while we may have answered a lot of the things that we need to understand, just from an understanding point of view, every time we answer a question about the sun or about any object, we usually come back with about 10 other questions.
The missing answers form the breeding ground for imagination and faith. In the far north, the Northern Lights hunters pay honor to the home star with a traditional sun ceremony.
We sit by the fire. The fire that ignites and warms. It is the sun of times gone by. Stored in the wood we burn. Sun. light, and warmth.
Det var en lang reise.
It has been a long journey.
I trommekraften.
And we can find this power in the drum. The drum brings the power to life.
Kraft. Til at vi våkner
So that we wake up and remember who we are, the connection from ourselves to the community and to nature.
Til naturen.
The sun is the solar system's biggest mystery. Will we one day succeed in unlocking all its secrets?